It's kind of fascinating that I hadn't, in all of the conversations about edge computing, I hadn't thought about space. And that's sort of the ultimate edge computing use case, isn't it? Even terrestrial communications, you want to pre-process everything so that your communication is as efficient and as latency insensitive as possible. Or you get satellite mapping where you want to pre-process it on the satellite so that you're only sending down the right information and you're not clogging up. Bandwidth at that point gets pretty expensive and pretty limited, I would imagine, or just high latency. But then you start to think about going out to the moon or mining asteroids. And yes, you're going to use edge computing because the cloud is far away. And that's a whole different sort of conversation. Have you given thought to what you do with space-based data? You can't just push that to the cloud and store it in an S3 disk. Not so easily anyway, unless Amazon really expands quite a lot. So deciding what's valuable and what you store and how you store it, because you have to launch disks and install them somehow. Data management becomes much more of a thing. Data processing, planning becomes much more of a thing. How do you decide? How do you run your data management type operations and your logistics operations when they're not terrestrial?
Yeah, you're so right in that space is the ultimate a use case for edge computing, right? And how far do we want to go, right? And latency is a real technical aspect of it. There's also, I think, the human expectation or patience around it. So that's a whole different point. But I think that the consumerization of space data and information that we don't really see as space data. It's just data, my GPS information, or tracking how far I walked. That's data that gets piped up to a satellite and beamed back up. So I think that's going to drive some of these requirements to lower latency. When you think about just the applications of edge computing, obviously there's satellite imaging. All the satellite imagery that is being collected can actually be processed on board a satellite instead of sending it back to the Earth, processing it, and then and this is actually really critical if you're doing disaster monitoring or tracking ships, etc. Now, satellite navigation is also important. You use edge computing on satellites to actually to process satellite navigation signals on board rather than sending them down. Space is a pretty crowded place now with the number of satellites there, different countries setting it up. So satellite navigation is a need. The whole field of satellite servicing and maintenance also would require edge computing, right? Because satellites, they are shut down or sundown. There may be refueling required in space. There may be repairs needed in space. So all of that will require edge computing. And then any kind of spacecraft autonomy. If the further higher up we go, you will need to use edge computing to run autonomous control algorithms on spacecraft, and that's going to be really important. And then satellite communication between each other, right? You're going to have to need edge computing to make some of that happen, to enable direct communication between satellites without actually having to send it back down to the Earth. Quite a few reasons for us to really think about edge computing as a real need that has to be in place. We can also potentially I'd expect edge computing to potentially even power a decentralized space data marketplace where users could buy and sell data directly from satellites, because satellites are, they track all kinds of data. You have companies who are, setting up satellites and providing data feeds. There's a whole ecosystem, a subculture around the usage of satellite data. So, some of those things are all, again, real and limited and critical. Obviously, the spacecraft have limited storage capacity. They have weight constraints. They have power constraints. Payload costs go up with the cost with the weight of what it's carrying to take up there. And there are also, cyber and very real security threats, right? Many countries have ASAT missiles. Some of the countries have tested them. And so data needs to be encrypted and processed. So, there are some real considerations as we think about edge computing. You asked around how do we decide what stays, what goes. Lots of IT folk are going to have to, understand the non-terrestrial aspect of data management. It's not just about running your WAN and your LAN. I think IT leaders and technologists are going to have to understand this intersection with data that gets piped from somewhere else. For that, we obviously there is a data prioritization aspect that needs to be done based on its importance and timeliness, right? You have to decide when does data get sent down. Many organizations look at the transmission of data at times, in the dark hours. So when, satellites are not actually, when they're orbiting, if they're, over the night sky, they're recording different things. Those are times. So there is that aspect of data prioritization, data compression, because data has to be compressed, because, the amounts of data we're capturing and sending back and forth are pretty critical. Data needs to be filtered because you don't want to send information which is not useful, right? So a satellite captures lots of different data. It could be images, could be telemetry data. You have to kind of prioritize and filter it out. And then you have to, cache it and really ensure that, you're picking certain data sets that are kept on the spacecraft so that it can be accessed quickly and then also encrypted. So, the whole aspect of data management in the real edge is a real, there are some certain considerations, and satellite operators have to use a number of different tools to automate the data collection, do the processing, and then, also for the security and accessibility issues. So a very interesting topic, and I think, it's going to become more front and center as time goes by.